Good afternoon. Again, we're looking at another example of proportional relationships and how to find unknown quantity using proportions, mathematical proportions. In this case, we're going to look not on the map, which is an example of a scale drawing, but we're going to look at the enlarged picture frame instead. Given, we have a photograph, right? Photo 1 and another copy which has been enlarged, photo 2. Notice we have the same building. On the original photograph. We have, let's consider this length, and this is width, 12 by 20. And on the enlarged photo, we have unknown length equals x, but we have width that's now 25 centimeters. In order for us to create a proportionally scaled photograph, we need to make sure that the building room looks exactly right. Well, how do we find out? We know the picture is enlarged. So again, what is given? We will write down given. Very important first question of every word problem in math. First question you have to ask yourselves, what is given? The second question, what needs to be found? So given, we have a relationship of length to width. And in the original photograph, it is 12 to 20. We can write centimeters. What is also given on an enlarged photograph, the width is 25 centimeters. Notice how I line up. I line up width under width and length under length. That's very important that we set up our proportion correctly. And what is the length of an enlarged photograph? X centimeters. That's something we have to find. My friends, we have ourselves a starting ratio and a second ratio, and we have ourselves a proportion. Out of 4 quantities in a proportion, if one is missing, is unknown, we can always solve for it. Now, remember in the last video, I showed you the butterfly method, or simply we multiply diagonally what is across, what we know, and divide by the third quantity. So let's go. We can say x equals to 12 times 25 divided by 20. We can reduce everything by 5 at first, and it becomes by 5. It becomes 5 to 4, and then we can reduce continuously, becomes 3 to 1. And therefore we're left with 3 times 5 equals 15 centimeters. That is the new solution we just solved for new length. 15 centimeters. Take a look at the solution given in our books. 12 to 20 is times 25. And of course, 12 to 20, we can say it is divided by 4. It is 3/4. And 3/4 times 25, 75, not quarters, 5/5. 3/5. And 3/5 times 25 is also 15. So the height of the building in the picture is 15 centimeters. Another way for us to set up this proportion another way to solve this proportion, remember, we did it diagonally, but another way we can say 12 to 20 is the same as x to 25. Let's do it this way. 12 to 20 has to be in proportion to x to 25. And notice, we can do cross multiplication, or we can simply reduce a fraction on the left. Remember, divide by 4, and we have 3/5. Let's rewrite it. 3/5 is an equivalent fraction to x to 25. Now, what needed to happen? Multiply 5 times on the bottom and on the right, and therefore x equals to 15 centimeters. Another point of view is we can say that we have a scale factor. We have a scaled factor from 20 to 25. That means we increased it 5 over 4 times, or 1.25 times. What we do to one distance, we do to another, and we can find our new height this way. I hope you found it useful.